Have you ever stared at a Western blot, one that's either totally blank or just a complete mess, and just thought, what on earth went wrong? Yeah, if that sounds familiar, you are definitely in the right place. In this explainer, we're going to turn that frustration into a super clear diagnostic guide to solve one of the most common headaches in the lab. So let's just dive right into that big question, the one that keeps researchers up at night. Is it your sample? The transfer? The antibody? A failed blot can feel like a crime scene with zero clues, but I promise, by the end of this, you're going to be the lead detective on the case. Okay, so just to make sure we're all starting on the same page here, Western blotting, it's our go-to tool for seeing if a specific protein is there and, how much of it we've got. We're basically using antibodies as these little highly specific detectives to go find our protein. It sounds simple, right? But as we all know, the devil's in the details. All right, so if our blot is a crime scene, well, in pretty much every single case, we have a prime suspect. And that brings us to the single most critical piece of the whole puzzle, the primary antibody. I'm telling you, if you get this part right, you are already halfway to a beautiful blot. This right here, this is the golden rule, and you really can't say it enough. You can have the most perfect sample, flawless technique, the whole shebang, but if you're using a crummy primary antibody, you are just setting yourself up for a bad time. It's kind of like sending a detective out with the wrong photo of a suspect. They're just never going to find what you're looking for. So what do we even mean by a quality antibody? Well, we mean one that's been properly validated, one that gives you real confidence in your results. A quick look here shows the key things to look for. First off, does the band actually show up where it's supposed to, at the right molecular weight? That's just a basic reality check. Then, can you actually change the signal with treatments? This is huge. It proves your antibody is finding the right protein because it behaves the way it should biologically. These are the kinds of things that make sure your antibody is specific, reliable, and gives you clean data time after time. All right, so a validated antibody is our best weapon. But let's be real, things still go wrong. So let's dig into our first major problem, what I like to call the ghost blot. This is when you've done all the work, you expose your film, and you see absolutely nothing. Or maybe, just maybe, the faintest whisper of a band. It's so frustrating. Let's figure out what's causing this ghost in the machine. So to be really clear about it, we're defining low signal as any situation where you just can't see your target protein after a totally standard 30-second exposure. If you have to leave that film on for like 5 minutes just to see a speck, yep, you've got a low signal problem. Okay, the simplest, most straightforward reason for a ghost blot: your protein of interest is just at such a low level in your sample that the technique can't possibly pick it up. It's there, but it's hiding. So how do we fix it? We've got to boost the signal right from the source. You've got options. You could try a different cell line that's known to express more of your protein, or maybe stimulate it with some chemicals. Make sure your lysis buffer is doing its job. Sonication can really be a game changer here. And honestly, the easiest fix is often just to load more protein. Bumping it up from 20 to 40 micrograms can make a world of difference. Okay, so you're confident your protein is in the sample. What's next? Well, the next likely culprit is the transfer step itself. Your protein might be totally stuck in the gel, or it might have shot right through the membrane. Either way, it's not where we need it to be. So let's break it down. If you have an incomplete transfer, you can try cranking up the time or the voltage, and keep an eye on your pre-stained marker. That's your visual guide. Now for overtransfer, which happens a lot with smaller proteins, you'll want to switch to a membrane with smaller pores, something like 0.22 micrometers. That'll help catch those little guys before they escape. Now this next one can feel a little backwards. I mean, we block and we wash to prevent problems, right? But being too aggressive, washing too much, or blocking for too long can actually cause a low signal. You might be masking the protein's binding site or literally washing your precious antibody right down the drain. And the fix here is super simple. It's all about precision. Block for 1 hour at room temp. That's it. Please never overnight. And for washing, a simple 3 washes, 5 minutes each, after your primary and secondary antibodies. That's all you need. Just stick to the clock, and you'll save your signal. All right, let's tackle the complete opposite problem, the blot blizzard. This is when your film looks like a crazy snowstorm. It's dark, it's messy, it's got tons of random bands, and it's basically impossible to see your actual target. So technically, we're defining high background as a film that's just generally dark or has a bunch of extra non-specific bands after that standard 30-second exposure. If your blot is messy and you can't make heads or tails of it, this is probably your problem.
And here we go. It's the flip side of our last problem. While too much blocking and washing kills your signal, too little creates that blizzard. If you don't block properly, your antibodies will just stick to everything, not just your protein of interest.
So getting this step right is absolutely crucial. Block for a full hour and make sure, and this is important, that your wash buffer is TBST. That T stands for tween 20. It's a detergent and it's essential for washing away all that junk that's sticking where it shouldn't be. It really helps clear up that blizzard. So if your blocking and washing are on point, the next place to look is your secondary antibody. This little guy can be a major source of nonspecific binding, creating a ton of background noise if you're not careful. Okay, here's your 4-step game plan. Always incubate your secondary in 5% milk and TBST. And a big one, do not use BSA here, as it can actually make the background worse. If you're still getting noise, try diluting your secondary even more. And here's a great pro tip. Run a blot with only the secondary antibody. If that thing lights up, you know for sure the secondary itself is the problem.
Oh man, this is such a classic trap. You've got a really faint signal, so you think, hey, I'll just expose the film for way longer. But what often happens is you just end up amplifying all the low-level background noise across the whole membrane, turning a faint signal into an unreadable mess.
And here is the simple fix. Just remember this number: 30 seconds. In a well-run Western, that is typically all you need. Exposing for longer almost never strengthens your specific signal, it just makes all the background noise louder. If you can't see your band in 30 seconds, you probably have a low signal problem, not an exposure problem. Okay, we have investigated all the clues, we've identified the main culprits. Now it's time to put it all together into a simple, handy checklist that you can take with you right to the lab bench. Let's close this case for good. And here it is, your at-a-glance diagnostic tool. If you've got low signal, the first 3 things to check are your sample prep, your transfer, and your incubation times. If you've got high background, look at your blocking buffer, your secondary antibody, and your exposure time. Seriously, this little table right here is your cheat sheet to solving like 90% of all Western blot problems. So there you have it, the mystery of the failed blot. It's not so mysterious after all, is it? It's really just a process of systematic diagnosis, one step at a time. So the real question is, now that you're armed with this guide, what's the first variable you're going to go and fix on your next run? Your perfect blot is way closer than you think.